Hi. For those who are away, let us begin it afresh. So our topic for today is the atomic structure, lesson number one. This is the first lesson with the form one, the form twos. This is the first topic of the form two. The date is 27th of July 2020, and the time is 4:30. I think maybe we are late with around some minutes. The objectives. By the end of this lesson, you should be able to, one, state the subatomic particles of an atom. You should be able to explain the properties of each subatomic particle. You should be able to state the atomic structure of the first 20 elements. The lesson is prepared and presented by Teacher Stephen Okech of St. Kevin Nyali Elite High School. The phone number is there. Maybe if you want these notes at the end of it, you can contact me via WhatsApp so that I can forward them to you. Let's proceed. Now, welcome to the real life. The reason why we are here, we are now starting with the atomic structure. So atomic structure. So a structure is how something is made. So the content of something. Like now how the atom, what atom is made up of. So that is the structure, how it can be drawn. So because when you are drawing the atom of a structure of an atom, you have to include all the contents, all the contents of the atom, which you will be able to know at the end of this lesson. So as per our first objective, we said that you as a learner, you as a student, you should be able to know and state the subatomic uh, atoms, the subatomic particles of an atom. So in Form 1, also you learned about the atom, the particles. You also learned about the molecules. You also learned about the compound. So as for now, we want now review what you have learned in Form 1. So in Form 1, we said that an atom is the smallest particle of an element that can take part in a chemical reaction. So the atom can take part in a chemical reaction. So you should be able to know that very well. You should be able to know that very well, that the atoms can take part in a chemical reaction. And you know that atoms are just smallest particle of an element that can take part in a chemical reaction. Then this atom is now made up of three subatomic. To mean the atom is divided into smaller atoms, the subatomic. Like we know that we have for example, we have the county, we have the sub-county. A county may have more than two sub-counties. Like those who are coming from Mombasa. Mombasa is a county, and we have Nyali sub-county. We have Kisauni sub-county. You see, so those are the sub-county. We have the county and the sub-counties. So like here, an atom also we have the atom as now the county. Then from there, we have now the sub-atoms, like the sub-counties. So what makes up the atom are now the subatomic. So the subatomic are what makes up an atom. And we have said that an atom is the smallest particle of an element that can take part in a chemical reaction. You should be able to know that. So what are these three subatomic of an atom? We have the first one, we have the protons. In singular, you can say proton, a proton, a proton, the article, the article, a proton. So A is the letter, the A, we call it A, is now the, uh, whatever I've said. Then we have also the next one. The next one is the electrons. In singular, we call it electrons, an electron. So that article an, because the word begins the sound. Your teacher of English taught you that very well. I will not be able to explain that better than him or her. Also, we have the neutrons as one of the uh, subatomic particles. So that one you should be able to know that. So we have three. The atom is made up of three subatomic. So the sub-county of an atom, there are three. That is protons, neutrons, and electrons. So we are going to discuss one by one. So the first objective that we say, you should be able to state and know the subatomic particles of an atom. And I know how to hear, you know them very well. Because at the end of the lesson, I'll be asking you some questions regarding the same. Let's proceed. In the next slide, now we want to begin with the protons as the first subatomic particles of an atom. Before we proceed, I want to ask a question. Who can state three subatomic particles of an atom? Very fast. We proceed. Yes, Tracy?
Protons,
Yes,
electrons,
yes.
and neutrons.
Very magnetic. You are very correct. You can now mute yourself. We have protons, electrons, and neutrons. Those are the subatomic particles of an atom. Now let's start with the protons, and we see the first one was the proton. In plural, we call them protons. So these are now the properties, or the characteristics, or the characteristic of the proton. You have to know this thing very well. If you know these things, writing the chemical equation will not be a problem. Knowing the number of energy levels of an element will not be a problem to you. Knowing the mass number of an element won't be a problem to you. It won't be an ill to you. Instead, it will be just a valley that you walk in with at ease. You walk through it at ease without any difficulty. Now let us see the first property of this proton, and we will be discussing one by one until we know everything from this. The protons is positively charged. So the protons are positively charged. They are positively charged. Positively charged means that they have this sign here. Let me take a pen here. Where's the pen? They have have this one here. Let me admit this person so that we can proceed. So to me, they have this sign here, being that they are positively charged. They have something that looks like this, positively charged. So this is the charge, which is positive. So the protons are positively charged subatomic particle. So they are positively charged particles. They are positively charged particles. So protons are positively charged particles. You should know that. Tafadhali. Hapa lazima mjue because they are examinable. You can be told to differentiate between a proton and electron. You can be told to state the properties of the proton. So you should be you should know that the first property, the protons are positively charged. Another one, the protons are found in the center of an atom called nucleus. So when we have, maybe if we have, let me admit those one. For example, if we have this as our atom, then atom is complete when there is this thing called nucleus. So nucleus is found in the center of an atom. So inside this nucleus, we have now this thing called protons, which is denoted by letter P. So inside that, we have that thing called the protons, which is the proton, which is found at the center of an atom. So know that the protons are found in the center of an atom, just the way I've explained here. Another property or the characteristic of a proton, it has a relative mass. It has a relative mass of 1. It has a relative mass of 1. So the proton as a particle has a relative mass of 1. Then another characteristic, the number of protons in an atom of an element, it is the same as atomic number. So to mean protons is equal to atomic number, 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 is equal to atomic number. So the number of protons of an atom of an element is equal to the atomic number of that element. Let's take for example, for instance, we have sodium. Sodium is atomic number 11. If sodium is atomic number 11, now what can tell us? Who can now tell us the number of protons of sodium as an element?
11.
11. Very magnetic. That is very correct. We have said that the number of protons of an element is equal to the number of atomic number of that element. For instance, we have talked about sodium, and we know that sodium is atomic number 11. So to mean the sodium also has 11 as the number of protons. Are we together?
Yes.
Thank you. Very magnetic. Thank you. Let us proceed. Let us proceed. So we are done with the proton. The next subatomic that we are going to discuss is now the electrons. Let us work together and make sure you understand this thing magnetically. If you have a question, you can ask. If no question, let's see the electrons, how it behaves, and the characteristics. the electrons. Now the characteristics of this electron, the properties of electrons of an atom as a particle. These things are particles. Proton is a particle. An electron is a particle. So let's see these characteristics or the properties of the electrons. One, electrons are negatively charged. To me, they have a charge which is they have a negative charge. There is a pen that I'm looking here, but let me just use this one that they are giving me. So we have said this one is negatively charged. So this is a charge which is negative. So that is the charge of the negatively charged, the negative charge. So electrons are negatively charged. In in other circumstances, you will realize that electron is written like this. Electron is written like this. Then the E with a negative there. So the electron is negatively charged. I've said you can write it like this. In most cases, you see it is written like this. I can see some. Please explain how protons have a mass of number one, please. Okay, let me finish this, then I'll be able to answer that because I've begun the protons. So thank you for that. I'll be able to explain it. Don't worry at all. So this is how we denote this one. Hi. Then they are found in the fixed regions surrounded by the center of an atom called the what? The energy levels or orbitals. Orbitals means they go round, they orbit. Like those who are doing geography. Those who are doing geography, you learned on how the earth revolves. You say that it orbits around the earth, something, I don't know, something like that. I did geography long time ago. I cannot remember, though I did the all sciences, geography, and business studies. Let's see this. How is this appears? So when we have the structure of an atom which is drawn like this, and we said that a structure is complete when there is this thing called the nuclear. So inside we have this nuclear, and we have said the first thing that we have learned, which is found within the nuclear, is proton, which is denoted by letter P. Then from there, we have said that the electrons are found in a fixed region. This is a fixed region. You can see this is a fixed region. So electron can be found there. You can see there is, maybe you can, we can have this as our electron. Let me admit somebody here. Thank you. You can see, you can see this one, that one can be electron, this one can be electron, like that, like that. We can also have another energy level, like that. Then we in energy level we can have another electron there, and we said that they are negatively charged, to mean there will be now that mutual force of attraction between the proton and the electrons. We said very well that uh, the like poles repels, but unlike poles attracts. So when the protons are negatively charged and electrons are no, when the protons are positively charged and electrons are negatively charged, there will be that mutual force of attraction. So that is what will make that structure to be formed, not to be separated because of that force. Very good. So we have also this one. We have this one. Another as another property of an electron. So it has a relative mass of 1 over 1840. You will be able to know that very well. You should be able to know that. Just master it the way it is. This is the relative mass of electron. So an electron has a relative mass of 1 over 1840. That is 1840. And the last one is now the last one. We have the last property of electron. The number of protons and electrons in an atom of an element is always equal. So they are always equal. The electrons and protons, their numbers are always equal. So, for example, if sodium has a proton of 11, the number of electrons of sodium also will be 11. That is why you will see the sodium has 3 energy levels. The first one will be occupied by, by 2 electrons. Another one will be occupied by 8 electrons. Then the last one will be occupied by 1 electron. So if you add all those electrons, you will get 11. So to mean the number of protons are equal to the number of electrons of an element. I've explained that very well. For example, if we talk about calcium, calcium has 20 protons. It has 20 protons and it has 4 energy levels. And each level is occupied by an electron. So if you add all those electrons you add electrons in first energy level plus the electron in the second one, the third one, and the fourth one. If you add them all, you will get 20. That will tell you that the number of protons of calcium is equal to the number of is equal to its number of electrons. Very good. We I know we are left with around 6 minutes. Let's see if we can finish it up before the time limit. So let's now talk about the neutrons. Let's talk about the neutrons. The neutrons. Very good. Neutrons. The neutral is neither if something is at neutral place, to mean it is at rest. It is at rest. To mean it is neither moving uh, or moving forward or backward. So it is at rest. Like the neutrons. Here we have been talking about the charges. Like we have said, the protons are positively charged, and also we have said that the electrons are negatively charged. So if you hear the word neutral, it means they are neither positively charged or negatively charged particles. So you should be able to know that. Very good. The neutral is neither positively or it should be neither nor or either. So here there was a mistake. We know that neither goes with the nor. So the neutral is neither positively nor negatively charged. Thus, it is called now neutral. Like if we go even to the acid bases and indicators, you also realize that we have the neutral solutions such as sodium chloride, such as water. So those are the neutral solutions. So to me, they are neither acidic nor basic. I think that is well understood. Like protons, another property, like protons, it is found in the center of an atom called the nucleus. So up to now, you know very well that the two particles are found at the center of an atom called the nucleus. So we have the protons and we have the neutrons. And the neutrons, we have said that they are neither positively charged nor negatively charged particles. So, for example, let me take my pen so that I can help you drawing. Uh, Take a pen. Very good. So, if we have, for example, if we have this, I don't know. So, if we have this as our atom, then inside an atom there is this thing called a nuclear. Inside the nuclear, we have the protons, and now we are now having neutrons. So we have these two things found at the center of the atom. They are found at the center of an atom. Another property of the neutral is that we are through with that. But another one which I've not included, you can write it at your own. So this you can ask the function of this neutron. It is what gives an atom stability. It gives an atom the stability. So it is what makes the atom to be stable. You can write that, please, if in any case you are writing. So another one, it gives an atom the stability. So it makes an atom to be stable. You can look the language that you can use, so long as the word stable or stability and the word uh, atom is there. So what gives an atom stability, the stability, is now what is called the neutron. So that is its function. It gives an atom stability. Uh, so it makes an atom to be stable. Let's see the next one. Let's see the last one, the last slide. Uh, the last slide, because we have only some seconds. We have only some seconds. Then we will continue from there. Or what you do, I'm ending it, then you come for only 5 minutes because we remain with only this and uh, and only the first 20 elements. Only that, then we will call it a day. Otherwise, those who are willing to come back, you can come back. We clear this, then we call it a day. That is how we should be working. Sawa sawa.
Sawa.
Uh,
Sawa.